Does hydropower combat climate change? Is there enough water for hydropower to be sustainable? Is hydropower cost effective? Those are some of the common questions that are asked about hydro and tidal power. Now, what is tidal or hydropower? Tidal energy, also called hydropower, is a renewable energy source from the water in the oceans and rivers. There are many different ways that you can use tidal energy, such as water turbines, dams, barrages, and generator buoys. Water turbines are a specifically designed turbine that functions much like a wind turbine, but instead of wind, they utilize the currents of the ocean to generate electricity. Currents goes past them, the water makes the blades, which are angled to catch the water efficiently, spin around, which generates electricity. Some types of water turbines are secured to the ocean floor, meanwhile others are attached to the floor by a cable and float near the surface. Dams are big walls that get built in rivers and will hold back lots of water and slowly release it through areas that have generators that spin when the water passes by, like a water turbine. The dams also have control over how much water flows through them. Most of the world has dams, and in America, there are a few in the Colorado River in the west. Barrages are similar to dams. Barrages are buildings that can generate power from the water's current and flow, but depending on the type of barrage, it can or cannot store water behind it. Barrages oftentimes slow down the speed of the river and divert water. Barrages are mostly used in Iran, Pakistan, and India. The tidal barrages are often built out across an inlet, and when the tide comes in, the turbines generate electricity from the current. But as the tide goes out, the barrage slows the release of water so that it can keep generating electricity from its turbines around the clock. Generator buoys, or power buoys, are buoys that are attached by a cable to a magnetic shaft attached to the seafloor. When the buoy goes up and down due to the waves, it generates electricity. Each generating buoy, as of right now, can potentially produce up to 250 kilowatts of power. The tidal range is an essential feature in how underwater turbines and barrages can generate electricity. The tidal range is the wavelength of the tide. Tides are like massive waves that, depending on where you are, happen once or twice a day. The tidal range can be used directionally for water turbines, so that when the tide is coming in or going out, the turbine can swivel around and make the most of the water. Barrages would have the water level rise and fall with the current, meaning that the hydroelectric turbines inside of it would generate electricity faster. The tidal stream often runs along the side of the coast and goes into estuaries and bays. The tidal stream, also referred to as the tidal current, also has a directional flow when coming into the shore and away from the shore. These are called the flood current when it is coming in, and the ebb current when it is going out. Hydropower can be used almost anywhere in the world with a body of water that has a current or a movement, like a river or the open ocean. The different ways that hydroelectric power is able to be used makes it extremely versatile and able to be used almost anywhere in the world, from rivers to the coast to sometimes even in the middle of the ocean. There's lots of research that has to go into where you place the power generators, and depending on the type of device, some work better than others in certain places. Like a hydro turbine would work better on the coastal shelf than a dam would, or a barrage would work better than an inlet than a generator buoy. The pros of tidal and hydropower are that it's a renewable energy source, it has high power outputs, and it's pretty predictable. Hydropower is a renewable energy source, meaning that unlike conventional power sources like coal, oil, and natural gas, it will never run out or be depleted. This is good because a concern about using fossil fuels is that eventually they will run out. Hydropower also does not have any carbon dioxide emissions, which means it does not contribute to global warming. Hydropower also has high power outputs, and a turbine that was placed in Scotland is generating enough electricity to power about 2,000 houses year-round. The O2, as the generator was named, can offset approximately 2,200 tons of carbon dioxide yearly. Hydropower is very predictable. Since the currents and waves are always there, you don't have to worry about the wind stopping or the sun hiding behind the clouds like you do with wind and solar energy. Since it's very predictable, you can easily estimate the amount of houses it can power or how much electricity it will generate. The cons of tidal and hydropower are the funding and costs, the maintenance costs and difficulty, and the environmental impact it may have. The funding costs of hydropower are pretty high. It costs a lot of money to get the construction crew to build everything. Since for most builds you have to make a foundation first, building that alone is expensive. Then it has to be underwater. Installing the parts is also expensive, as you have to ship them to the build site on a boat and then pay a crew to dive and assemble it, or construct it on a ship and then lower it into the water. The maintenance of hydropower is also a complication. It costs a lot to constantly maintain eroding paints, metals, and other materials. The maintenance also has to be done underwater, unless you want to make it more expensive by pulling it out of the water for maintenance. And some things like dams and barrages you can't pull out of the water. The environmental impact of hydropower is a concern. If it is a dam, it blocks the whole river up, and it would have a massive impact on the ecosystem. Meanwhile, if it was a generator buoy, it would just bob there, not really affecting anything. Water turbines also spinning around could hit marine life if the marine life is not paying attention. I think that even though there are disadvantages of tidal and hydropower, I believe that we need to invest in it, as it is one of the most reliable sources of renewable energy. The advantages of hydropower, in my opinion, are way bigger than the disadvantages. As a final closing statement, I'd like to state how tidal power is a very good way to combat climate change, even though it does mean we would have to spend lots of money to make it a major power source. The ocean is massive, and even though the environment is something we need to take into consideration if we expand it into the hydropower industry, it should be seen as an essential step forward in power generation.